Hello, I am Naseem, and in last couple of videos we try to understand the basic fundamentals of probability, how to calculate probability of an event which is a part of sample space of a random experiment which we have done. We also try to understand how to calculate conditional probability and multiplication rule of the probability, which we already discussed in our last video. Now let us try to discuss one specific problem set to calculate probability, right? For example, we have two different bags, and in this bag we have bag 1, we have another bag which is bag 2, we have number of balls of different colors inside bag 1, we have three different balls green and four different balls green in bag 2. At the same time, we have um, four different yellow balls in bag 1 and five different balls in bag 2 which are of yellow color. Now it is pretty simple. We already discussed how to calculate. We are already know how to calculate probability when we have given the sample, sample space of the experiment. We can calculate probability of yellow or or green color balls if we have given the bag, means the bag from these balls is given. For example, someone is saying us what is the probability of yellow ball from bag B1. We can easily calculate, because yellow are four different balls we have yellow in bag 1, so total number of favorable sample space in bag 1 is 4, means yellow ball, and total number of balls inside this is 7. We are simply able to calculate 4 by 7, which is probability of yellow ball in bag 1. Same, we can calculate probability of yellow ball in bag 2 when we have given bag. So probability of yellow ball in bag 2, we have 5 yellow ball out of 9. So the 5 by 9 is the probability of yellow ball in bag 2, right? This is how we can calculate probability. But can we find the probability that the ball drawn is from a particular bag, say bag second? What is the probability that a specific ball has been drawn from bag second if the color of the ball is given? So what does it mean? We need to find out probability of bag when color of the ball is given. We need to find out this. We cannot find it simply. We must have something else, right? And Bayes theorem is the thing. Bayes theorem is the thing which help us to find out probability of the bag when we have color, means the color of the ball is given. So in next couple of minutes in this video, we will try to understand Bayes theorem, right? So prior to going to Bayes theorem directly, we must have some prerequisite. We must have some understanding of some topics, right? And these topics will be, what are the partition of the sample space? The first topic would be partition of sample space, and second topic would be theorem of total probability. So prior to directly jumping into the fundamental of Bayes theorem, we must have knowledge of these two different topics, right? And what are the partition of the sample space and theorem of total probability. So let us try to understand. We have a experiment done, and this experiment is having S, which is a sample space, and with this sample space we have a number of events. Let us call them E1, E2, E3, E4, and same like En. We have n number of events, right? We need to find out whether these E1, E2 and En, means these different events related to same sample space, whether these are partition of the sample space or not. So to decide it, we have three different conditions. So the condition one is each of the events must have greater than 0 probability. So the probability of the very first condition is the probability of each event must be greater than 0, means probability of each event must be greater than 0. This is first condition. Second condition is that the union of each of the events of this sample space, E1 union E2 union E3 and same union En, must be S, means sample space. right? Third condition is that intersection of any of the events must be always null. I mean, EI intersection EJ is always null for every I and j equals to 1, 2, 3 till n. This is the third condition, right? So decide these things means to decide whether E1, E2 and En, I mean different events of a sample space, whether these events are a partition of the sample space or not, we need to check these three conditions. If these conditions are met, all the partitions, all the events of that sample space are the partition of the sample space itself, right? This is how we can check whether the given events of a sample space are the partition or not. So this is one thing. Second thing, we will now continue to understand the theorem of a total probability. So once again, let's consider we have a sample space, and inside the sample space we have a number of events. So we have a sample space S, and we have number of event E1, E2, E3 and En, right? We have different events of the sample space S, and also it is already assumed that these E1, E2 and En, all of the possible events of this sample space are the partition also, all right? And we are considering these events of the sample space are the partition also, means these E1, E2 and En are proving these three conditions, is these three conditions are true. So these E1 and En, all of the events of the sample space are partition, right? Now let us consider we have another event A of the same sample space. So we need to find out probability of A. Then theorem of total probability is saying that we can find out probability of this event A by this formula. P of A will be equals to P of E1 multiply P when A given, probability of A when E1 given, plus PE2 PA E2, and like that we have PEN PA En. So this is the formula of total probability. I mean, when we have a sample space S and we have E1, E2, En are the events of the sample space S, and these events are also the partition of the sample space, and we have, for example, another event which is A, and we need to find out probability of A, then this is the formula by which we can find out probability of the same. This is how this theorem of total probability is saying us. This is how it is helping us. If we wanted to make it a standard formula, then this is how we can make it. So probability of A will be equals to, starts from I equals to 1 to n, and how it is PEI multiply PA EI. This is how we can calculate probability of a given event inside the sample space S, and this is what theorem of total probability, right? So we are now ready with these two things, means we already know what are the partition of the sample space, we already know what are the theorem of total probability. Now we will be able to jump into the Bayes theorem. I have attached some documents regarding the proof of this equation. If you wanted to find out, if you wanted to study deep down into it, same document has been attached here with in the description of this video. You can go and you can check it out, right? Now let's talk about Bayes theorem. Once again, let's consider we have a number of events of a sample space S. So we have E1, we have E2, we have E3, and in the same manner we have n number of events of a sample space S. All right, we have a sample space S. These events are partition of the sample space S, means these all the events are proving these three conditions. The probability of every event is greater than 0. The union of all of the events will be sample space itself, and the intersection of any of the events will be null every time. for every I and j. Now let's consider we have another event of the sample space, which is A. We have another event and we wanted to calculate probability of EI when A is given. This is what we need to find out. Means we have two different bags. We have number of balls inside these bags of different color. We wanted to find out probability of bag, right, when the color of the bag is given. Means A is the color of the bag and we need to find out probability of bag itself, right? How to find out it? Just apply formula of conditional probability here. So when we need to find out P E of F, probability of E when F is given, we need to find out probability of E intersection F and probability of F itself, right? So just apply this formula here. What we'll find out? P EI A would be equals to P EI intersection A P of A itself. Now just put this PA means the probability of finding total probability, theorem of total probability. Just put this formula here. So what we will have is that PA we have, this is PA according to total theorem of total probability, right? Now we have multiplication rule of probabilities, which says us that the PEI intersection A is equals to PEI multiply PA intersection EI. So just put it here. This is a multiplication rule of probability and this is theorem of total probability, right? Just put these two formulas here, just place it. What we will find out is that PEI when A is given is equals to PEI multiply P A is given when EI is given divided by J starts from 1 to N P EJ multiply P A EJ. This is what Bayes theorem says us. I have attached same document into the description link of it. If you wanted to study this Bayes theorem of total probability and multiplication rule of probabilities, you can go and check it out. It is very, fundamentally, if you wanted to clear your issues or something, just drop your query onto the given email. I will be back. And this is how we can, calculate probability of a bag when color of the balls which bags are holding, and you need to find out this probability of the bags. This is how, by putting this formula, by using this formula Bayes theorem, we can calculate these all the things. I hope you like this video. If you have, in case of any doubt or something, just go and drop me a mail on the given mail ID. And as a supporting document, I have given a link of the documents into the description of this video. You can check out the documents as well. Thank you for watching this video.